Okay, so this is our last lesson on area. And so we're going to talk about the area of similar figures today. Remind me what similar figures are, similar polygons. Yes?
Figures that have the same dimensions.
Okay.
But the side lengths are different.
The side lengths are different, but what is their relationship? They're proportional. Okay, good. And so you've got proportional sides, and you have corresponding angles that are congruent. Now, the sides are proportional, so if you know some of them, you can see a proportion. You have to figure out the missing ones, right? Okay? But the areas of similar polygons are proportional, but they're not directly proportional to the side lengths. So we're going to talk about what you have to do there. The area of similar polygons, if two polygons are similar, then their areas are proportional to the square of the scale factor between them. Okay? So what that says is that if you have two similar polygons, you can take the area of one is to the area of the other as one pair of sides squared is to the other one squared. Okay? For example, or you could use their scale factor. All right? So let's say that this had an area of 9 units squared, and this had an area of 25 units squared. Okay? And then this thing here was, this one right here, let's say, was 6, and this one was 15. Okay? Alright. Basically what happens is you can set up a proportion with the area. Okay? You can do 9 is to 25. Okay? But when you set up the other side, you have to square the sides. Okay? It would have to be equals 6 squared to 15 squared. Okay? In order for it to be proportional. Alright? The reason being is because area is in square units. Your length is in units. So you can't set something proportional, something that's got square units, to something that just has units. Okay? So if you would set up a proportion, you have to do area to area, side squared to side squared. Now another thing you could do is you could take those sides and you could find the scale factor. And the scale factor is basically the ratio of the sides reduced. And so this would reduce to what? 3/5. So instead of using 6/15, you could do 3 squared instead of that. Do this. Oh, sorry. Okay. So you could do, 9 is to 25 as 2 squared is to 5 squared. Okay. So you can use the scale factor or you can use the side lengths, but they end up being proportional either way. You just have to make sure whether you use the sides or whether you use the scale factor, you have to square it if you're going to set the proportion of the area. Okay, so let's do a few examples. All right, it says triangle JKL is similar to triangle PQR, and the area of triangle JKL is 30 inches squared. Find the area of triangle PQR. So we're looking for this right here. Okay. So you're given side lengths, right? And we can tell by the similarity statement that JK does correspond with PQ, right? So we can take those side lengths and we could reduce them if you wanted to, okay? Or we could just use the side lengths to find the area. So we can take side squared to side squared, area to area. And so we end up with 144 over 225 equals 30 over x. So we end up with 144 equals 225 times 30. And then divide both sides by 144. And you get 46.9. Okay. And like I said, you could have used the scale factor also. I could have found the scale factor between the sides, which could have been, let's see, 12 and 15, which that reduced to 4 fifths. Okay? And so if I had used the scale factor instead of the sides, I would have still had to square it. 4 squared is to 5 squared, as 30 is to x. And you would have gotten the same answer. Okay? So you can use the side lengths, or you can use the scale factor, but when you set it up with a proportion, you have to make sure that you square the side lengths. And that's the biggest mistake that I see, is people will set this up 12 is to 15 as 30 is to x. You can't do that. You understand that? You have to take the sides and square it if you're going to set it proportional with area. Okay? Alright. Now they might ask you to go backwards. The area of ABCD is 150 square meters. The area of FGHJ is 54 square meters. If they are similar, find the scale factor and find the value of x. Okay, so on this one, let's see, it says ABCD is 150 meters squared. Okay, and then FGHJ is 54 meters squared. Okay? Alright, so we want to find the scale factor, and we want to find the value of x. Okay, so, if we go to find the scale factor with the areas, okay, you have to understand that if you're using the areas, then the scale factor is squared. Okay, so if I set up a ratio of ABCD to FGHJ, okay, which would be what? ABCD would be 150 over 54. Okay, if I set up to find the scale factor, you have to understand this is areas, right? So we actually find the scale factor, I would need to reduce this and then take the square root. Okay, so reduce it and then take the square root. So what goes into 150 and 54? 6 does. Okay, so it goes in there how many times? 25 and 9, right? Okay, so that's still the ratio of the areas. I want the scale factor. Okay, so if I want the scale factor, I take the square root, okay, which gives me what? 5/3. Okay, so that's my scale factor. It's 5/3. Alright, then it wants me to find the value of x. Now at this point you have a choice. If I use the scale factor, I can set up a direct proportion. Because it asks me to do ABCD to FGHJ, that's 150 over 54, that reduces to 25/9. Okay, but you're good? Okay. Alright, so the scale factor is 5/3, right? That's the ratio of the sides reduced. I can do a direct proportion with the sides, okay? I can set up a proportion 5 is to 3 as, let's set up the other side, 10 is to x. I can do a direct proportion because they're both dealing with meters, okay? And I would cross multiply, and I would get 5x equals 30. And so x is 6. Okay? Alright, so I found the side lengths, and I found the scale factor. You don't. Okay, but they might ask you to on some of them, but you wouldn't have, all it said was find x. You didn't necessarily have to do that. Okay? You could have set up the proportion with the areas. Okay? Yeah, and that's probably what I would do, is I would have probably, I would have done 54 is to 150 as x squared is to 10 squared. Yeah, that's probably what I would have done if they hadn't asked me for the scale factor. But you do need to be familiar with, like, your area scale factor and your side scale factor. Okay? You need to understand what those are. Yes.
So, even if like I'm not trying to find a scale factor, could I just simplify 54 over 150? I know it would give me a scale factor.
Right. So, or you could have set it up as 25 is to 9, but you still would have had to have done x squared is to 10 squared. You could have done that also. Because even if you take this ratio of the areas and reduce it, it's still a ratio of areas. It's just reduced. Okay? Alright? Does everybody understand that? Okay. Alright. Here's another one. The length of two similar rectangles are in a ratio of 2 to 3. If the area of the smaller rectangle is 12 square meters, what is the area of the larger? Okay, so we've got the lengths are in a ratio of 2 to 3, and we know the smaller one. So what are we going to have to do? Set up a proportion. Okay, so we've got the ratio of 2 to 3, right? Okay, you're backwards. You are going to do 12 over x, but this is area, right? And 12 is area, so what has to be squared? The scale factor, right? So it should be 2 squared over 3 squared equals area over area. Does everybody understand that? Okay. All right. So we end up with 4 over 9 equals 12 over x. We end up with 4x equals 108. Is that right? 108. And then divided by 4 gives me 27, right? 27 centimeters. I also think that 4 times 3 is 12, so 9 times 3 is 47. That was pretty easy. Okay, here's another one. Alright, since the area of one side of the skyscraper is 90,000 square feet, the area of the corresponding side of the scale model is 200 square inches. If the skyscraper is 720 feet tall, how tall is the model? Now, this one is working with feet and inches, but that's okay as long as your proportion is feet to inches, feet to inches. You're good, okay? And so what I would do is I would make one side of the proportion represent area, and then I would take the other side that represented the height. But what are you going to have to do to the height? You have to square it, right? Okay? So I would take one proportion of 90,000 to 200, and I would probably reduce this and use, at least use 900 over 2. Then you can reduce that more. I would at least use 900 over 2. So that's still area, okay? And then on the height, what did that give you? 720 for the skyscraper, right? And I have to do what? Square it over this height squared, right? Okay? So I end up with 900 x squared equals, you can do all this in your calculator. I have to write it down. Which is 1,036,800. And then I probably divide both sides by 900. And then take the square root and do that all at once. So the second square root, 1,036,800 divided by 900, which is 33.9. And since it's the height of the model, it would be in what? Inches. Okay, so the height of the model is 33.9. Alright, any questions on what I did there? Your numbers today probably won't be quite this big. Alright, last one. The perimeters of two similar rectangles are 54 centimeters and 72 centimeters. If the area of the larger rectangle is 224 centimeters squared, find the area of the smaller rectangle. Okay, so if we're talking perimeter, it has the same scale factor as side lengths, whereas the area doesn't. Okay, so we could use the perimeter just like we would use the side lengths to find the scale factor. Okay, yeah, you'd have to square it, or you could take the perimeter and reduce it and find the scale factor and then square that. Because those are kind of big numbers. You wouldn't have to. You could do 54 squared and 72 squared. It would work. The numbers would just be really big. Okay, so how would we want to set it? You want to find the scale factor first, or do you want to just directly set it up? Okay, find the scale factor? No, you want to just set it up? Okay, so how do we set it up? 54 squared over 72 squared. Okay, so they give you the larger one, so your x is your unknown, and then this would be 224. Okay? So we have 224 times 54 squared, which is 653,184. I would probably go with some stuff. 72 squared, 5184 times x. And divide by 58. Now, if I had found the scale factor, I would have taken 54 over 72, but 9 doesn't go over those, right? It's 6 over 8, which is really 3 over 4, and then I would have done, let's see, that's 3 squared over 4 squared, and then x over 224. So you would have gotten the same answer.